I hope that you remember this problem coming from your homework, and I'm following the picture, and then I am collapsing the object into a dot, and here we go with FT1 and FT2. Particularly one student asked me about this at the end of the class, but I was busy and I couldn't really help him, and that's why I am redoing this problem again. So here you have all the forces, and setting up the tables at this point should be easy for all of you. This is your x table, and ft1 along x direction, ft2 along x direction, fg, and then ax is 0 because it is not moving anywhere. And here you have ft1 cosine 30, that is obvious. And the second one, here you are taking this angle with respect to the positive of x-axis, which is not 30, it is 150. Don't forget, this is your positive x direction, and here we are measuring this angle in the counterclockwise direction. Therefore this one is ft2 cosine 150. And fg does not come into play because it is an angle 270 degrees, and that angle, if I mark using a different color, here you have that blue 270 degrees. So if I plug the numbers in, ft1 0.86, and here you have ft2 0.86, and then this term goes away, and that's pretty much it, right? So let me actually redraw these lines, and the x is 0. So if you use sum of fx equals to mass times ax here, here you have ft1 times 0.86. This is actually the algebra. By the way, I made a mistake here. This should be negative 0.86 right over here. Not cosine 150 is negative 0.86. And going back to this equation, ft2 0.86, or should I use that as negative 0.86 over here, and this side you have mass times 0. So you got ft1 0.86 and negative ft2 0.86, and the other side you have 0. And if you just divide everything by 0.86, actually first let me take this term to the other side, divide both sides by 0.86, that means 0.86 gets cancelled out, and you end up with ft1 equals to ft2, and this is our first equation. Now we go back and then set up our y table, because we did not obtain the ft1 or ft2 from that work that we did. So we are going back and setting up the y table. So once you set the x table, setting up y table is pretty easy. ft1, ft2y, and fgy, and all what you have to do is changing cosine into sine, because we have measured everything with respect to the positive x direction in counterclockwise direction. That is why our lives actually are easier, since we follow the rules here. Fg sine 270 here. So ft sine 30 is a 0.5 ft1, and sine 150 also is a 0.5. So 0.5 ft2, and then here fg equals to mg, right? We know that fg equals to mg, and sine 270 is a -1, and this side you have 0. So let's take these things together, and now let's work on the sum of fy equals to mass times ay. And here you have 0.5 ft1 plus 0.5 ft2 and minus mg equals mass times 0, because ay is 0 again. So 0.5 ft1 plus 0.5 ft1, these two together makes a whole ft1. Why do I say that? Because this is the same as ft1, So instead, because we know that ft1 and ft2 are the same, so I substituted for ft2 as ft by ft1. So you have 0.5 ft1 plus 0.5 ft1. And then let's continue, equals mg, this side 0, and ft1 equals m times g. And I don't remember exactly what we had for m. Let's say it is 1.5 kilograms and g is 9.8, and the answer for ft1 sorry ft1 equals, and this is the final answer. If since ft1 and ft2 are equal, ft2, that's the tension on the other string, also is 14.7.